Okay, so here we have a question about it's about a lot of stuff, but it's given the graph of f prime. So we're probably going to have to use the concept that integration is an accumulator of a rate at some point because this is the graph of a rate. But let's just see where it goes. So they're saying this is the graph of f prime, and they're giving these two areas. This area is 9, and you can read this in the text down here. And we're trying to find, for part A, we're trying to find all the x coordinates at which f has a relative maximum. So this is a very simple question because the definition of a relative maximum, the reason, which I'm going to give right now, is the derivative. So for f to have a relative maximum, its derivative must go from positive to negative. In other words, that would make the function go from increasing to decreasing, but you don't want to use that reasoning on an AP exam. So you want to use because f prime goes from positive to negative. So we're given the graph of f prime, so you have to figure out where it goes from positive to negative. So where does it go from above the x-axis to below? And that's exactly at x equals -2. So there's my answer, there's my reason, we're done. Next question. Concave down and decreasing on what intervals? So give a reason. So I'm going to give the reason again. It's concave. For a graph to be concave down, its derivative must be decreasing. So it's concave down because f prime is decreasing. So I have my reasoning for being concave down. That's always a reasoning for concave down. And where's the graph? Decreasing. Well, a graph is decreasing when the derivative is negative. So I've given the reasoning for both. You need to know that reasoning to answer the question. But then once you have the reasoning, the answer to the question is simple. Just figure out where this graph of f prime is decreasing, going down, and negative below the x-axis. So going down below the x-axis, going down below the x-axis. So these intervals would be at -2 to -1, and then 1 to 3. Pretty simple. But you have to know your reasoning. Next question. Find the x-coordinates for all points of inflection. This is, again, very simple. A point of inflection happens when the concavity changes. So when it goes from concave up to concave down, since we're giving the graph of f prime, that's when the graph of f prime goes from increasing to decreasing or vice versa, because that would be concave up to concave down or vice versa. So increasing to decreasing or vice versa. Or you could even say it's where the graph of f prime has relative extrema, because that's where it's going to go from increasing to decreasing or vice versa. So right here, decreasing to increasing, right here, increasing to decreasing, and right here, decreasing to increasing, or those three relative extrema. So x equals -1, x equals 1, and x equals 3. So it would be impossible for us to get y coordinates because we're not given any other information. So that's good. Just x coordinates, we're done. Now here's something where we are giving some information and we are trying to find y coordinates. So this is where integration as an accumulator comes in. We're given the graph of f prime. So remember, if you integrate a rate, you're just going to get the antiderivative f and the fundamental theorem of calculus, which give you this. So this is the net change of the actual function, not f prime, but the actual function from b to a. Now, that's not enough to give us any values of a function. We would need to have an initial condition. So you use the initial condition and then you add the change from where the initial condition starts to where we end. So the change from where we had the initial condition to where we're trying to get to. So the initial condition here is f of 1 equals 3. So we know where we are at x equals 1. So these two questions are just saying, all right, where we are at x equals 4 and x equals negative 2. Well, the concept here is, we start at a value of 3, and then find the change from 1 to 4, and then from 1 to negative 2, and just add it to where we started. So where we started plus the net change, which is this. So the explanation is kind of wordy, but the process is pretty easy. F of 4 would be, well, we know at f of 1, we're at 3, and then you just add the net change from 1 to 4, which would be the integral of this rate. Now, this integral is going to calculate area as long as it's above the x-axis. It happens to be below 1 to 4 is the area is 12. So this would calculate, the integral would calculate that as negative 12. The net change is negative 12. So we have 3 minus 12. So f of 4 is negative 9. And then f of negative 2 is just as easy, except you have to, I guess you have to watch out here. So, because when we try to do f of negative 2, we don't do it any differently. We're still starting at a value of 3 at 1. And then the change, we're starting at 1 and we're going to negative 2. The reason why I thought you may have to be careful here is because from 1 to 2, remember we're going backwards. So even though this area is 9 and the integral normally counts it as negative 9, since we're going backwards, the integral would count this as positive 9. So we just have 3 plus 9, which is 12. So that's it. That's the last question. Very typical AP exam type question. So hopefully that clears things up. Go Rams.